We're doing a 6-7 today.
Yes. We're doing 6 out of 7.
Okay.
Review from the test on them.
All right. And then the test is gonna be on 5 and 6. All right.
Okay, so, 6 out of 7. And then review, sample, exam. We can revisit 6.6 if you want to get more practice on application square problems. Okay. 6.7, rational functions. Oh, let me put it open. Rational functions, evaluate a rational function, find the domain of the rational function, simplify a difference quotient, EQ, and graph rational functions. Okay, back to our definition. A rational function is any function that can be written in the form of polynomial divided by polynomial, where of course the denominator is not 0. So this, up until now, we've been talking about rational expressions. And we were simplifying them, add, multiply, subtract, divide, all those operations out. Now, we're going to talk about not expressions, but functions. Remember our definition of a function, each x is exactly 1 corresponding y. So each element in the domain, that's the x values, the independent variable, has exactly 1 corresponding element in the range, that's the y value, that's the dependent variable. It depends on what x is. So that's a function. So now these are rational expressions that are function, polynomial divided by polynomial. So the first thing we're going to do is evaluate them. So here's a simple one, f of x So that tells us this is a function. X minus 4 over x minus 2, evaluate it when x equals 0. So it looks like that would be minus 4 over minus 2 is 2. It's 2. F, evaluate the function when x equals negative 4. F of negative 4 means negative 4 minus 4 divided by negative 4 minus 2 is negative 8 over negative 6. Simplify that, 4/3. Okay, simple and natural, right? Just put that number in for x. Turn the crank. Just so you know, you can have a 0 numerator, no problem. 0 divided by 2 is 0. You cannot have a 0 denominator. Negative 2 divided by 0, you're going to write undefined. It does not exist. That's it. That's evaluating functions. Rational functions at some x value. Next, the domain. So the domain is the allowable x values. And for the most part, well, unless there's restrictions in the description of the story problem or function, then the only restriction for us is the denominator cannot be 0. So in this first case, this function, x minus 4, x minus 2, x can be anything except 2. So here's one way of writing it. Braces means the set of all x such that line means such that, x does not equal 2. The set of all x such that x is not 2. That's it on that. Anything except 2. Second problem, anything except negative 1. The third function, anything except 3 or negative 3. Okay, wow, that's that. Okay, next. Difference, seems like a hodgepodge stuff here. Difference quotient, DQ. Not Dairy Queen, difference quotient. Here's a diagram. So now look at this. Now we're talking, these are not linear functions, right? These difference functions are in general not linear. So the red is the graph of the function. And we see that we took a couple points P and point Q that are on the function. And we could calculate the slope between P and Q, and that's going to be that blue line. So you can see early on, the function is actually a much steeper, more positive slope than the blue line. But then it slacks off right here and actually comes down even. So over the entire period, the slope is rise over run. This value Q minus the y value P, the rise, and then the run is x minus 8. So this slope is called the difference quotient. In the formula for it, you don't need to memorize it because I'm going, when it's on the test, I'm going to give you the formula, which is not this. It's coming up in the next example. It's a lot like this thing. Let's go to where it gets. Here we go. The slope of the line through points PQ is m the slope, and this is the formula. F of x plus h minus f of x, that's the rise. As you can see in the diagram right here. The rise is f of x plus h minus f of x, that's the rise. Divided by the run is x plus h minus x, which is so this point P is x, the coordinate is x by f of x. And this point Q, his coordinates are x plus h by f of That might have made a little bit more sense. Maybe some of it. But this is the way. All right. So, evaluate the difference quotient. Here's how we do it. By the way, difference quotient is like kind of a preview into differential calculus. Because that's what you're going to be doing, only much more efficiently in differential calculus. Well, let's look at example 5. So, f of x, our function that we're going to be working with, is 3x minus 5. And the difference quotient is f of x plus h minus f of x, that's right, divided by the run, which is just h, x plus h minus x, just h. Okay. So first we need to evaluate f of x plus h. So in the function, everywhere there's x, I'm going to put x plus h. And then I'm going to subtract f of x, meaning 3x minus 5, after that, divide the whole thing by h. So here we go. F of x plus h is 3 times, instead of x, it's going to be x plus h minus 5. Distributive property does 3x plus 3h minus 5. Oh, that's where it is. And you can see when we do the difference quotient, here's f of x plus h. And then we're going to subtract f of x, which is 3x minus 5. And don't make sure you get this. Oh, the distributive property is going to be minus 3x. Minus minus makes it plus 5. A lot of sign errors, so if you're right there when people forget to do that. This negative applies to everything. Okay, all that divided by h. Oh, all we have to do is simplify it. You see 3x minus 3x. And minus 5 plus 5. So a lot of terms cancel out at this stage. Anyhow, we're left with 3h over h. H cancels h, and the answer is 3. Well, this was the world's simplest problem. So what does it mean? The difference quotient really is the average slope over some range. And our simplistic function that we picked is 3x minus 5. A linear equation, it looks like that. So you can pick any point, any p and any q anywhere you want on here. You calculate the average slope between these 2 points. Well, it's a straight line, so it's going to be identically the slope, right? Which we already know. Is 3. But we calculated the difference quotient anyhow, and it's right, it's 3. It's close. Just because it's just a straight line. So it doesn't get interesting until we get nonlinear equations. Example 6. Oh, here it is. Nonlinear. X squared minus 4. Okay, difference quotient. F of x plus h. So everywhere there's x, we put x plus h. So x plus h squared minus 4. Okay, and then we're going to subtract f of x minus x squared minus 4. Remembering that minus minus 4 is going to make it a plus 4. So when we square this guy, x plus h times x plus h is, FOIL it, x squared plus 8hx plus another hx plus h squared. Then we're going to subtract 4. Then we're going to subtract x squared, and then minus minus 4. So there's a ton of cancellation. X squared cancels x squared, 4 cancels 4. And I get only 2 terms, 2xh plus h squared. And you can see I can factor an h out of there. H times 2x plus h. And then lastly, h is a factor in the numerator. It cancels h as a factor in the denominator. And the answer is 2x plus h. Finito. But if you draw the graph, it might make more sense if you can actually look at it. So, See that? This graph, f of x is x squared minus 4, it looks like this. It's a symmetrical, it's a parabola, symmetric to the y-axis, so it looks like that. So we can pick any 2 points anywhere on here, like I'll pick this point for P, this point for Q. So this would be f of x plus h. This is f of x. That's x. This is x plus h, which makes a run h. Like this here to me. X plus h minus x is h. Okay, so there is h, and then from here to here, that's the run, a rise. That's f of x plus h minus f of. So get our dq, and we calculated it to be 2x plus h. Remember, dq is the average slope between any 2 points that we select. Now, in differential calculus, you're going to select d and q to be like right next to each other, right in the limit, will be right at the same spot. The slopes of this quadratic change. It's not like a linear equation where it's constant forever. The slope right here is, very negative. Isn't it kind of negative? Zero slope, slightly positive slope, even more positive slope, a very large positive number. So the slope at any point, it's always changing. It's given by this formula, 2x plus h. Now, when we pick p and q to be like super close to each other, h is extremely small. In fact, it's negligibly small. And our slope basically is 2x. And that's kind of what differential calculus is all about. It's 2x. So here, when x is 0, the slope is 0. Here, when x is 1, the slope is 2 times 1 is 2. Here, when x is 15, the slope is 2 times 15, it's 30. Hold on. Very steep. So, why is this even in here? That's a good question. It's in here because it's a rational expression. The dq, differential quotient, is a rational expression. A polynomial divided by h. That's a polynomial. Okay, that's why it's in here. Any questions on dq? Okay, next. Here's the main part of it. 6.7 is graphing rational functions. This is like thinking that you're going to plot these graphs by hand, I think. No, or you're going to do it on a calculator. I don't know what. What's our example? 6 divided by x minus 2. The graph looks like this. And what they want to show you is the characteristics of the asymptotes. So there's vertical asymptotes, like in this equation, where the function is not defined. Look at f of x is 6 over x minus 2. X could never, ever be 2. Right? So at 2, it's undefined. So what happens at x equals 2? Well, the function never gets there. Coming from the right, it approaches 2, but it just takes off towards 0. And coming from the other direction, as it approaches x equals 2, it never gets there. It goes down to negative. So this vertical line, vertical asymptote, it's undefined. Function never gets there. Likewise, there are horizontal asymptotes. And in this case, it's kind of hard to see, he didn't highlight it, but at y equals 0 is a horizontal azimuth. So as x becomes gigantically huge, the graph will approach y equals 0, but never get there. And likewise from this direction, it will approach y equals 0, but it will never get there. On this side, it's approaching from the negative y values, and over here on the right, it's approaching from the positive y values. But it never gets to y equals 0. So that's a horizontal azimuth. That's it for that. Vertical asymptotes and horizontal asymptotes. Vertical asymptotes, that's when the denominator would be 0, but that's not going to happen. Horizontal asymptotes, sometimes they're a little bit, they're not more difficult to identify. Yeah, sometimes. This is when we do it. Using technology, punch this in your calculator and save the file. We're just going to talk about it for now. Here's example 8 is another graph, 6 over x plus 2. You can see x could never, ever, ever be negative 2. So vertical asymptote at negative 2. And then in this case, well, it's the same thing. All we did was move the thing over here. I mean, a couple. Okay, let's go. Okay, maybe this is a little bit more interesting. The function, here, let's get the function, x minus 4 over x minus 2. So we can see what can we know immediately, x could never be 2, so there's a vertical asymptote at x equals 2. And then we're talking about the horizontal asymptote. Okay, so here's the vertical asymptote at x equals 2. It kind of looks the same, except now the horizontal asymptote occurs at y equals 1. And the reason it occurs at y equals 1 is we're talking about x minus 4 over x minus 2. Think about what happens to y when x approaches like 100 million. Okay, a really big number. It's way out there. Way out there. And yet, well, 100 million minus 4, divided by 100 million minus 2. Well, when you're that far out, this minus 4 and minus 2 are really insignificant. So basically, we're talking about x over x, which is 1. So it's approaching y equals 1 when it's way out there. And in the negative direction, same thing. When it's way out there, a negative 100 million divided by negative 100 million, give or take a couple loose coins, it's just going to be 1. So that's what's happening. That's why it approaches 1 from above, and here it approaches 1 from below. Oh, that's it? Okay. It's not, okay. We did the simple cases. It's not always that simple because you can have graphs that go like this, where this is like some line or an angle. This is the vertical asymptote. So there are other things other functions that it could be approaching. But we're just doing the simple ones. Okay. That it? Let me check my notes. Let me get one slide. Yeah, how about let's do some quadratics. F of x is not the simplest quadratic of all, x squared minus 4, but it is x squared plus 3x minus 5. So now, when we do f of x plus h, I have to do x plus h squared plus 3 times x plus h minus 5, all the math, minus the function x squared plus 3x minus 5. So, first term, all that divided by h. X plus h squared, oh, that's a perfect square, is x squared plus 2hx plus h squared. Then distributive property plus 3x plus 3h minus 5 minus x squared minus 3x minus minus makes it plus 5. All of that. And then you can see where I canceled terms out, x squared minus x squared, 3x minus 3x, minus 5 plus 5. Got a lot of cancellation. I end up with 3 terms on top. Those 3 terms have a common factor h. So I pull h out of there. And then the factor h cancels the factor h. And thus our answer is 2x plus 3 plus h. Yeah. Oh, and what's the graph of this guy? Here's a graph. Oh, well, it's hard to tell. But the red line is the blue line is the actual function, and the red line is the average slope between those 2 points, x equals 0 and x equals 2. One the same. Now here's some special cases. This was in the book, maybe not. Maybe I'm just adding it. Special cases of graphs of rational functions. The first one, y equals 1 over x. It looks like that scaling is funky here in this graph. Sorry about that. But the point I want to make is that this function is symmetric to the origin, which means origin, 0 by 0. That is an odd function, which means if you rotate the function on the y-axis and then on the x, or it doesn't matter which order you do them in, but you rotate it twice, you'll get the other half. If I take this curve and then I flip it on the x-axis, and then I flip it on the y-axis, I get the other half. So those are odd functions, symmetrical to the origin. The next example is symmetrical to the y-axis. This is y equals 1 over x squared. It looks like that, and you see it's rotated on the y-axis. Just flip it right over. Oh, I hate these graphs. I got to redo these graphs. Okay, this rational function is a polynomial divided by polynomial. I factored it to make it easier for me to graph it. But it looks like this. And you can see it has vertical asymptotes at -4 and at +2. It has a vertical axis at -4 and at +2. And it has a horizontal axis at, well, again, we're just doing simple cases. When x is like really huge, x squared dominates everybody else in the numerator. X squared dominates everybody else in the denominator. It's basically x squared over x squared, which is 1, which means way out there, it's going to approach y equals 1. In this case, they're both from above. Well, what happens in between these two vertical asymptotes is this little blip like this.
6 and 2.
Okay. Sketching the graph. Oh, this is right out here. Graphs of 2 rational functions are given in 7 and 8. Use the graphs to find the following. Which one are we doing? 7 or 8? Is both of them? I don't know. Okay, f of 2. Well, in this graph here, f of 2, the y value when x equals 2 is y equals 2. In this problem, f of 2 is y equals 3. This is just evaluating these functions. Just put these numbers in and calculate what it is. Do that problem. Do that problem. Do that problem. This is something else entirely. This is also something else entirely. Oh, that's it. I think that's all we can expect from 6.7. So 6.7, really two things, is the DQ, you're gonna have to calculate it. And being aware that the graphs have vertical asymptotes, where the denominator would be undefined, and horizontal asymptotes, which is where the function approaches as x becomes extremely large, either positive or large. That's it for chapter 6. Next, chapter 6 review. Oh, maybe review sheet. That was combined with chapter 5. Chapter 5, 6 review. Right here. Okay, it's pretty short. It's like 2 pages. 2+ pages. Okay, definition of polynomials. All of the exponents of the variables are positive.
Positive.
We did addition and subtraction. That means combine the like terms. The like terms, same variables to the same exponents. We did multiplication. Every pairing gets a chance, and then you combine terms. We did division, which for the most part is long division. Synthetic division, we're not going to do that. It's just shorthand of long division. We did factoring. First thing you always want to check on factoring is greatest common factor. That'll simplify everything else you got to do. If you have 4 terms, that means factor by grouping. First 2, last 2, like that. Doesn't work, rearrange it, try again. Simple trinomials. For us, they're always going to be, we're going to look at the integer factor pairs of the tail, and then when you get the pairing, look at the signs, so you get the right signs for the middle term and the last term. So integer factor pairs of the tail, and then watch the signs. Complex trinomials, we had this longer process. You could do trial and error if they're really simple, limited possibilities, but otherwise you multiply A times C, write the integer factor pairs, look at the sign, are we adding or subtracting them, pick the one that will give you that middle term coefficient that you need, split the middle term that way, factor by grouping, and you'll get it. You'll get it. Special products. Okay, this is the stuff I have to memorize. Okay, in yellow, memorize these guys. A perfect square. Actually, you don't have to memorize. You can just square. But you know, if you see it and you recognize it, then you know it'll make it faster to do the problem. But you can just multiply them out. Those 2 perfect squares. Then we have the difference of 2 squares. A squared minus b squared is a plus b times a minus b. Then we had the sum and difference of 2 cubes. And the layout is the same. The only thing different is, you know, it's a binomial, not a trinomial. The only difference between the 2 is where is the negative sign. So for the sum of 2 cubes, the negative sign is in the trinomial. And for the difference of 2 cubes, the negative sign is in the binomial. And here's some simple examples. Okay. You had to catch them. We combine stuff to make them disguises as best we can. Okay. Here's factoring to solve for x. Okay, so solve for x. We factor, and then we solve each factor equal. Oh, I'm going too fast. Put it in standard format. Everything equals 0. Then we factor. Then we solve each factor equals 0. I have all the answers. For scoring problems, discard extraneous solutions that are outside the domain. Okay, so especially for story problems, the domain will have additional due to physical characteristics, such as you can't have negative time, those kinds of things. So discard extraneous solutions. LCD, we've hit on that a few times, the lowest common denominator. We need to do that for adding rationals. What is it? It's each distinct factor in the denominator raised to its highest power. Okay, rational. So to add rationals, we had two methods here. We could get each individual term to have the same LCD denominator, or you can just get the LCD and multiply both sides or everything by the LCD, and it will all shake out as well. Less thinking, but maybe more work but less thinking. Okay, we talk about complex numbers. Start at the deepest innermost level and work your way out. First, I'm going to add 1 to 2 over 3 plus 4. Then I'm going to flip it and multiply. Solve right, so we'll talk about that. Applications. There were 3 application problems. Work is rate times time, and we're going to have multiple people working. Usually they work at the same time, but not always. They could have different times. They'll all be in the story. Then we had distance equals rate times time problems, which you can see from the formula is really basically the same thing. And we had some geometry problems. These formulas you should all know. So if you don't know them, just memorize them. Area of a rectangle is length times width. Perimeter of a rectangle is 2 times the length, so 2 times the width. The volume of a rectangular box is length times width times height. Pythagorean theorem, hypotenuse squared is a squared plus b squared. And the area of a triangle is 1/2 the base times the height. If you don't, just memorize. Okay, lastly, difference quotient that we talked about. It's a slope between 2 points. The average slope between 2 points. In graphs, the main thing on the graphs is to identify the vertical and horizontal axes. Okay, that was the review. Next, I printed next. Any questions? Next is sample test. I printed it out. So we're going to go through it all, but I think
This one's not a grade though, right? For the sample test?
yeah,
No? All right,
it's
cool.
just a study guide.
All right, cool. Cool.
Okay, so the real test that we have one day has 15 problems. The sample test has more because I just wanted to. I just wanted to do more, I guess. But the test is only at 15 problems. I'm looking something like this now. No problem.
Appreciate. Yes.
I want to make sure I didn't miss anything. Okay, problem number 1 is just, exercising, multiplication. So we got a binomial times a binomial. You can FOIL it, you can do it horizontally or vertically, any way you want. I didn't read it. I did all this work. Let me pull it up. Where is it? Oh, where is it? Sample solutions. Okay, so x times minus 3x don't know what order I did it in. X times 4, 5 times minus 3. Anyhow, the middle two terms combine, and we get our answer. Minus 3x squared minus 11x plus 20. Let me make this. Problem number 2, solve for x. Okay, so we got to get everything on one side equals 0. Let me see, what did I do? I got everything on one side equals 0. And then I said, what's the LCD? So I looked at the denominators 4, 8, 4. 8 is the LCD. So I can force each individual term to have an 8 denominator, or I could just multiply the whole thing times 8. Not even think about it, this, which is what I did. 8 times everybody. So 8 divided by 4 is 2. 8's cancel, middle term's 21. Okay, so I get quadratic equation, standard form equals 0. Let's see, greatest common factor. Nope, nothing I can do. So I'm going to do the long approach, which is AC. 2 times 10 is 20. Everything's positive. Great. I don't have to worry about subtraction. So 20, I'm going to write all the integer factor pairs of 20. 1, 22, 10, 4, 5. That's it. Which one of those will give me 21? The first one. 1 times 20. 1 plus 20 is 21. So I'm going to split that middle term, 21, up to x. 1x plus 20x. Split the middle term. Factor by grouping. First 2, x is coming out. X times 2x plus 1. And the second 2, 10 is coming out. 10 times, again, 2x plus 1. So fully factored, 2x plus 1 times x plus 10 equals 0. The two solutions are -0.5 and -10. Problem 3, division. Division is like long division. Oh, I did synthetic division here in green, just ignore that. I'll just look at the chicken scratch stuff over here. Long division, x goes into x cubed, x squared times everybody. X squared times x is x cubed, x squared times 5 is 5x squared. Underneath this like term, subtract. First terms drop out. That's how we get. Secondly, I get -3x squared. We become the next victim, minus 25x. First term x goes to the first term minus 3x squared, -3x times. -3x times everybody. 3x squared, minus 3x squared, minus 15x. Subtract, so we change the minuses to pluses. First term drops out. And I get minus 10x. Bring down -3. First term x goes to the first term -10x, -10 times. -10 times everybody. Subtract. We have a remainder. Yes, the remainder is 20. So our answer is x squared minus 3x minus 10 with a remainder of 20. Well, it's like that. And ignore the synthetic division, which is the same thing, except less writing. All good? Yes.
Like, I was looking at the one above it, I was trying to figure out, but how do you get x equals -1? Like, how do you get 2x plus 1 and x plus 1?
Oh, it came from over here. So when I had this polynomial equals 0, the method is multiply a times c. In other words, 2 times 10 is 20. Then I wrote all the integer factor pairs of 20. 1 times 20, 2 times 10, 4 times 5. Which pairing, when added together, will give me the middle 21, and that's the first guy here. So instead of writing 21x, I wrote 1x plus 20x. Then I have 4 terms, so I can do factor by grouping, first 2, second, first 2, next comes out.
Oh, I could. All right.
Oh, bless me.
Okay.
Excuse me.
Number, well, they're not numbers, so the next one. Oh, darn it, it's another one of these complex trinomials. Only, with bigger numbers. Well, luckily, I can at least get a 3 out of everything, so that helps. The other thing about this problem is, look at it, it's not x squared and x, it's x to the fourth and x squared. So remember, everything you do is gonna be x squared. Okay, that same process, AC5 times negative 16 is negative 80. All the integer factor pairs is negative 80. Which factor is negative? So one of these is positive. The difference has to give us the middle term of 16, negative 16. And it's the positive 4 and the negative 20. It's a pair that gives me negative 16. Okay, so this is how we'll split that middle term up. Negative 16x squared is plus 4x squared minus 20x squared. Factor by grouping, first two, that's two. First two, x squared is 29. Second two, 4 is 29. And what the rest? Negative 4 comes out, so then we get 5x squared plus 4, and again, 5x squared plus 4. Okay. So factors like that. Oh, wait a minute, we're not done. X squared minus 4, difference of 2 squareds. X squared minus 2 squared, so it's x plus 2 times x minus 2. Now here's my 5x squared plus 4, and here's this 3, but we pull it out way at the beginning way up here. And that's why it says in the problem, it says factor completely. Just don't do, I used to say factor, and some people say, oh, I factored down to 3, that's what you asked for, factor. No, I had to say no, completely, you gotta go all the way. Any questions on it? Here you go, factor completely again. This time, when you see there's only 2 terms, so that kind of tells you where we're going with this one. It's gonna be the sum or difference of squares or cubes, that's it. So this is the sum of 2 cubes. Okay. It's a good idea to write it that way so that you don't halfway through the problem forget. It's 3x squared quantity cubed, right? Because 3 cubed is 27, x squared cubed, power to a power multiplied, 2 times 3 is 6. So it's a cube plus a cube. And here's the formula that we memorized. Binomial times the trinomial. Binomial, it's a cube. Binomial a squared minus, that's what the minus one is, ab equals b. And just plug in these guys. A is 3x squared, b is y, just plug those in there, and that's it. There's nothing else you can do. Remember on this test, every problem I've been graded on 5 points, regardless of how easy or hard it is. Okay, so the next one's gotta be the easiest problem on the test. So evaluate p of 3, so evaluate when x is equal to 3.
Oh, yeah.
So 4 times 3 cubed, minus 5 times 3 squared, minus 6 times 3, it's 9. Turn the crank is 54. Next problem is simplify. I just want you to multiply this all out and combine like terms. So x plus 3 squared is x squared plus 6x plus 9. You wouldn't believe how many people forget the middle term, 6x, and they just write x squared plus 9. Oh, there's a middle term there, 3x, and it's 6x, the middle term, it's that either. Distributive property, minus 4 times x, minus 4 times minus 2 is a plus 8. Okay, that's a potential sign error that somebody's going to make. Run like that. Okay, let me know if I'm going too fast. It's okay? What, another one of these? I can't believe it. No, here's another one. Complex trinomial.
Can I get that?
Did I miss it?
No, I would.
Oh, they're 20 times 6, all the integer factor pairs of 120. This is like just to make you work at it. How am I gonna get 7 out of that? Well, keep going, eventually you get there. Oh, 8 and 15, that will give you 7. Split the middle term, factor by grouping. Like we've done this 3 times already. So I'm just thinking about it. Factor completely, this is, okay, we're not disguising it, it's gotta be factor by grouping. First 2, last 2. The square comes out of the first 2, -4 comes out of the next 2, so that I get the same, x plus 5, x plus 5. No, what, I got an extra work to do, difference of 2 squares, gotta do that. X plus 2, x minus. These are all kind of smallish size numbers because it's the process and the principle of it is, more important than the actual numbers. We don't want to get bogged, since you're not using calculators, we don't want you to get bogged down in big numbers. Factor, 2 terms. And we're subtracting, so that tells me it must be the difference of 2 squares, probably. Okay, greatest common factor, that's what we always do first, and in this case it's 2. Now I see it's 3x squared and 5 squared. So the answer is a plus b times a minus b. A squared minus b squared. A plus b equals minus b. That's it. Next one, long division. What? This time, long division, you came out with a 0 remainder. That's cool. Well, we're not gonna have. I'm not gonna have duplicate problems. We already did a long division problem, right? I don't know why long division is on here twice. Okay, next. List the domain. Oh, this is the second easy. The domain, that's the allowable x values. There's nothing but the equation for us to work with. So we see when we factor the denominator, x plus 6, x minus 6, we see the domain is x can be anything except 6 and negative 6. So you can write it any way you want to write it. You can write it like this in set notation, or you can write it out in words, all real numbers except 6 and negative 6. Or you can write it in interval notation, however you want to write it. Is that this? Oh, all real except 6 and negative 6? Yes. That's all right. Oh, is it? Okay. Isn't that the symbol for all real? Yeah, that's a symbol for all real, right? Never seen it.
Excuse me.
Like that. Because you said it's Steph, not equal, you're writing this, I can read it, it's all real that are not equal to 6 or negative 6.
That's just how it.
Simplify the rational expression. Oh, we just got to factor and cancel factors. Okay. The numerator is the difference of 2 squares. 2 plus x, 2 minus x. The denominator is a perfect square, x minus 2 times x minus 2. Now, once it's fully factored, it's like, oh, there's nothing to cancel. we have to pull a -1 out of this guy so that it will be something that we can cancel. You gotta remember that trick. Then I can cancel the x minus 2 guys. It's not a perfect match. Maybe all you have to do is pull out a -1, and it will be. Okay, next. Oh, this is a long problem. It is a long problem. This was that one section where we're adding really large rational expressions. Subtract these two rational expressions. Remember, we're subtracting. This minus sign applies to everybody in here. Okay, let's factor. Let's factor. So I'm gonna write factor here. And then I wanted the LCD. So I need a x plus 1, x plus 2, and x plus 3. That's the LCD. So now I'm going to get LCD for each individual term. The first guy's missing x plus 2, so multiply by 1. This guy's missing x plus 1, so multiply by 1, x plus 1 over himself. Now they both have that same LCD denominator. Numerators, I gotta multiply all this stuff out. This binomial times this binomial times 2, and this binomial times this binomial. We'll FOIL up and write that all out. And it's a lot of terms, but there's plenty of that can be combined. So it all combined to be x squared plus 7x plus 12. Is that factorable? Oh, it is factorable. It's x plus 3 times x plus 4. Okay, now fully factored numerator, fully factored denominator. I can cancel x plus 3 cancels. That's it. And we're done. Oh, that's a beautiful problem. So this problem had identified LCD. You had to do a lot of factoring. And then you have to do a lot of multiplying. A lot of terms to combine. There's a lot of that. All right, next. Simplify this complex one. I don't know. I like this problem so much. Here, I wrote it out, but it's really kind of hard to read. But I want to show you the way you're going to tackle it is you go to the deepest level, resolve this level. 1 minus a half is a half. Then you're going to resolve this level. 1 over a half is 2. Then you're going to resolve this level. 1 minus 2 is -1. Then you can do this level. 1 divided by -1 is -1. 1 minus -1 is 1 plus 1. Interesting. Go to the deepest level and just work your way out of it.
So you can say that again.
Sure. We're starting at the deepest level, which is 1 minus a half. 1 minus a half is a half. 1 over a half is 2. 1 minus 2 is -1. 1 over -1 is -1. 1 minus -1 is 1 plus 1 is 2. Sometimes it seems silly, but there's just a reason for it. Simplify the rational expression. So a rational divided by rational. Oh, invert and multiply. let's straighten that out first. Okay, now let's back. So the first guy we're gonna do is 3x cubed minus 3, we'll pull a 3 out of there, and then see that it's this difference in 2 cubes. Which we memorized, that is going to be x minus 1 times x squared plus x plus 1. And over here, I just pulled that 6 out of here, 6 times x 1. Okay, so that's it. So what is cancellation? All x minus 1 cancels. 2 times 6 is 12, 3 times 4 is 12, so those numbers all cancel. X cancels x. Oh, and x minus 1 cancels x minus 1. Everybody ended up canceling except for this simple trinomial in the denominator. I'm gonna write this on here. Well, except for that. Okay, next guy. Solve for x. We're gonna get everything on one side equals 0. First, let's get rid of these fractions. The LCD is x squared. Multiply everything by x squared. We could do each individual term, but we just hit it all in one whack. Everything times x squared. So x squared times 1. X squared times 1 over x is x. X squared times 6 over x squared. We cancel it 6. Okay. Everything on one side equals 0. Accurate. The solution is 3 and negative 2. When you know how to do it, it's really kind of simple. But I see people struggle for 10 or 15 minutes trying to add to this side or flip to that side. They don't realize that, just multiply both sides by x squared resolves all the headache parts of this problem. Okay, next. Let's solve for x. Okay, again. Oh, it looks like I used the same approach. Well, I factored those denominators. I pulled a 2 out of the first one and a 4 out of the second one. And I said the LCD looks like is 4 times x minus 3. Just multiply the whole thing by that. Now get rid of all of our fractions, no more denominators to worry about. So the first term, 2 goes to the 4 2 times, so 2 times 3 is 6. And the second term, I got all that. It's just going to be minus x minus 1. And then the right-hand side of the equals, it's going to be 4, 16 times x, 16 times 3. So, the 1, get everything flattened out for us. Combine terms, get all the x's on one side, divide by, in this case, 17. Okay, sorry about that ugly fraction. It kind of makes it hard to verify your answer. If you were going to do that, but. Okay, we're catching up to the difference quotient. Difference quotient, so it's a quadratic, x squared minus 3x minus 6. Look at this, I'm giving you the formula, here it is. You don't have to know it, but, kind of simple anyhow. Rise over run. The hard work is doing all this multiplication. So x plus h squared, it's x squared plus 2hx plus h squared. Negative 3 times x, negative 3 times h, minus x, minus minus makes it plus 3x, minus minus makes it plus 18. So plenty of opportunities to make a sign mistake. But when you get there, things just begin to cancel out like crazy. And it should work out just like this. You'll get a denominator which lets you factor an h out of it. Then you get h cancels h. Get your answer and write it in this decreasing degree order, which means the x terms, the numbers, and then h degree. Okay, last problem on this. We didn't do any story problems, so here it is. Last problem is the story problem. We spent all that time on it too. A pipe can fill an empty tank in 8 hours, so it works at the rate of 1 tank per 8 hours. A drain can drain a full tank in 16 hours. So the rate of the drain is 1 tank negative 1 tank per 16 hours. So half as fast as the pipe. If the tank is 25% full and the pipe and the drain are both open, how long will it take to fill the tank? So it's already 25% full, so we only need to do 3/4 of the tank. So the word, I think I wrote this backwards, is 3/4 of the tank. Very good. 3/4 of the tank is the word. And the pipe, 1 tank per 8 hours, that's the hours. My drain, negative 1 tank per 16 hours, that's the same 3 hours. That's our equation. I just multiplied it over by 16. So that gave me 2t minus t equals 12. Oh, t is 12. So on this problem, the thing, don't forget that you're only doing 3/4 of the tank, not the full tank. That's it. Now, the other type of story problem that we had in this section was, this is shared work. The other one was, distances, rate, times time. Now that's the canoe going upstream and downstream. The airplane going with the wind and it gets some back down. So this kind of makes it look like there's only going to be one story problem on the test. Okay, 1 or 2. So it'll be like this. I'll have to whack a couple of these problems to get it down to 15.
What day is the test?
Monday.
And you still want post notes, right?
Yeah. You have the solution posted, right?
Yes.
Yes. Oh, so in the meantime, it's like anything you want to go over, again, in more detail or more story problems that you want to see, because we can't do all of them. Okay. I think we did get to it. On all the story problems. Yeah, we did, but it's Can we get this page refresh? There we go. Okay, wait, let's do this one. Is there a number on the let's do this one right here. Can we do this the boat problem? Problems will start to sound like. Yeah, two, because I remember the curves too. Maybe I'll just pull it up. We did this debate group. That one. We did do that. I guess we did all of them. This one I don't think we did. Doug and Elaine painting your roof? Yeah, we did this one. It was the right problem to it into. Like, I don't think we did this one. Okay, let's do it. Inlet pipe can fill an empty pool in X hours. Oh, so this time it's unknown how long it takes to fill. Okay, the drain can drain a full pool in Y hours. Oh, we don't know either one. We don't know either rate. Oh, my gosh. Okay, the pool is half full and both inlet and drain are open. How long will it take to fill the pool? Find the time as a function of X and Y. Evaluate to find the time when X is 10 and Y is 15. So first, we're going to do the generic X and Y. So the rate, so the equation is the amount of work, which is fill it half of a pool, is the rate to fill it minus the rate to empty. Tanks per hour. One tank equals tanks per hours times hours. Tank per hours times hours. Part of the tank minus part of the tank is, okay, yeah, so our units look good. Okay, the work we're doing is half the pool. So as far as filling it, it's one pool per X hours per, one pool per X hours times T hours. And we're gonna subtract, because we're draining one pool for Y hours, that's the same T hours. So this is our half a pool, filled minus drain. Okay, so what did we do? We factored out T, okay, good. Okay, so here's our rational equation here. The LCD is, I've got a 2, an X, and a Y. So the LCD is 2XY. I'm just going to multiply the entire both sides of the equation by 2XY. Get rid of all my fractions at once. 2XY times a half. 2XY times 1 over X. The X's cancel, and I get 2Y. And 2XY times 1 over Y. The Y's cancel, and I get 2X. I factored that 2 out. Here's my equation. And we're solving for T. It says solve for T. So divide by 2 times Y minus X. There it is. So the time to fill that pool when it's already half full is the rate to fill times the rate to empty divided by 2 times the rate to empty minus the rate to full. That equation. Okay, now he says evaluate that equation when X is 10, Y is 15, and it turns out to be 15 hours. So not really doing anything different than what we've done before, just that instead of numbers, he told us to use X and Y for the rates. See if that would be enough to just throw you off. I think we did this one, it was 18 minutes. I think we did this one too. This one I skipped. Should do it, should do it. Kayak race 450 meters downstream, return 450 meters back upstream. Use the time. B, I must have copied this. V is the kayak speed, assume it's a constant, even though it's not. C is the current, assume it's constant, which is fairly constant. Right? Distance is rate times time. D equals RT, or solving for T, it's T equals D divided by 100. Okay, downstream, the rate is kayak plus current. Going upstream, the rate is kayak minus current. Okay, round trip time is 450 divided by the rate, downstream rate, plus, go back, 450 divided by the upstream rate. Okay, this equation, are we going to use the LCD? Yeah. The LCD is B plus C times B minus C. LCD. Oh, so now I got some numbers. Oh, okay. Let's put the numbers in. T is 300. C is 2. The current. Right here, we're multiplying everybody by the LCD. Okay, so it's 300 times that difference in 2 squared. 450 times B plus C and 450 times B minus C. I mean 2. Okay, it's kind of all number crunching at this point. Get everything on one side equals 0. Well, the greatest common factor, which in this problem is 300. Okay, now I got some small numbers, I can deal with this. It's V minus 4 times V plus 1. V minus 4 is 0, then the kayak is V 4. And if V plus 1 equals 0, the kayak is either minus 1. We can throw that away, it's outside the domain. Because the domain for the kayak is the kayak speed must be greater than the current. Most definitely can't be negative. So the answer is kayak's going 4 meters per second. That's part A. Part B, assume the same distance with the total round trip time be in a still lake be less than, equal, or greater than the time of the oh. I asked the test to vote on this. Okay. So now, the current is 0. Okay, like we're in a lake and there's no current. We're in a lake. Assume the same distance, 450 meters. Round trip, each way. Will the round trip time be the same? That was 300? Is that what it was? 300 seconds? Yeah. Or would it be less than 300 or equal to 300? Okay, so how many people think the round trip in a lake would be the same as a round trip in the stream? Same kayak. Nobody. How many people think a round trip in the river is faster than a round trip in the lake? 450 and 450. How many people think that doing it in the lake is going to be faster than in the river? So it sounds like the one is the round trip would be faster because you have a current.
Use a steamboat.
Was that?
Use a steamboat. A steamboat.
It's a kayak. You're sunk if you're doing that.
No.
Okay, here's the answer. The answer is. The lake is faster. Nobody said that. The lake is faster. Okay, so let's think about it. Same distance, do it in the lake is faster than doing it upstream and downstream. It seems like, upstream, downstream, they cancel each other out, so it should be the same.
Yeah.
Nobody said it would be the same. And then it's not.
No.
It's not the same. Right, which one is
A
faster?
lake is just, it'll move
Just a
the
kayak.
same rate the like nothing, same speed, everything, but the river, the river got turmoil, right?
Here's the, yeah, but that's not the reason.
I know, but I'm just.
Yeah. You're right. Yeah, there's all these other factors that make this not a really fair comparison, but ignoring all those other factors, the current is helping you for part of the time, and it's hurting you for part of the time. The point is, it hurts you for a longer time than the time it's helping you. I'll show you.
Like, does it matter if you go upstream first
And then downstream?
downstream?
No, it doesn't matter. What matters is how long are you spending time being helped versus how long are you spending time where it's hurting you. Okay? You have less time receiving benefit of the current than you do getting penalized by the current. Okay, so, for example, well, this format is messed up here. Ooh, there it goes. Okay, downstream, you're gonna spend 1 hour downstream and 2 hours going upstream. So you're spending 2 hours being penalized by the current, and only 1 hour getting benefit from the current. So it's not equal. Versus the lake, it's just a wash. There's no help, there's no hurt, it's just you. So in the lake, he does it in 2 2/3 hour. When he's being penalized for 2 hours and helped for 1 hour, it takes him 3 hours, much longer than in the lake. The river, you get 1 hour benefit, 2 hours penalty. More penalty than benefit, so the river takes longer than the lake. Let me skip that, it's not a question. Want to see more? I can pull some more out of the book.
So the three types
Oh, you have to skip the first one.
What's the name of this one?
That is a rate problem. Shared work rate, and then what's the other one? Just one of the numbers. Yeah, well, this one was dumb and this one was we are dead. We pick another one out of the book. The one we did was the sum of reciprocals of 2 consecutive even integers. But let's pull another one, different one out of the book. 676. Number of problems. 6.6. I'll pick one at random, anyone you want. All right. No, let's do number 8. It's messy, plenty messy enough. Find the number that you would add to both the numerator and denominator. This is the same number? Okay. Of 8/11ths, so that the result is 6/7. So 8/11. I'm gonna add some number to each, and that is gonna equal 6/7. Hopefully that's the hardest part, is getting the equation right. Because of the way, the way it's worded, which is often poorly worded, and it just is very confusing what it was supposed to do. In this case, we're gonna add some number to each numerator and denominator, and it's gonna equal 6. Okay. How are we gonna, what's our approach gonna be? Give her fractions. That's like by the LCD. What's the LCD? LCD is 7 times 11%. Yeah. Oh, no. So, first term here on the left, 11 plus n cancels 11 plus n, so I'm just doing 7 times 8 plus n. And on the right, the 7's cancel, and I'm left with 6 times 11 plus n. Okay, 56 plus 7n equals 66 plus 6n, n equals 10. Okay, let's see if that's right. If n is 10, I've got 8 plus 10, 11 plus 10, I've got 18. Oh.
It'll do 21. $11 plus 10.
Oh, thank you. What am I doing? That was one, where is when I get that?
You got Diet Coke.
No, I got it right here, I didn't even start it.
Get that Diet Coke.
I think I should have, my throat is, starting to lose it.
Yeah, we don't need you, passing out.
Okay, so let's simplify that, I guess, 3's going into each of those. Yep, 6/7, that's what I wanted. So, I think, in this problem, it seems so unnatural. Such an unnatural thing to do, but I guess it could happen. They didn't give some background on why you would ever want to do it. This is what it could happen. Try another one. Oh, 7, it sounds like the same thing. Let's see if there's something a little different here. Okay, we'll do number 4. Here we go. The sum of a number and twice its reciprocal. X. Twice its reciprocal is 1 over x. So twice the reciprocal is 2 over x. Equals 27 over 5. So here, the LCD is 5x. This is multiplied by 1 by 5x. Five x squared plus 10 equals. Okay, Okay, we'll put it in standard form. Yo, what? Now we gotta factor this. Okay, AC is 5 times 10, 50, all the integer pairs of 50. There they are. Now the middle term is negative, and the tail is positive, so these are both gonna be two negative numbers. You gotta combine to give us 27. It's those guys right there. X squared minus 2x minus 25x plus 10. Factor by grouping, first two has two. First two, x. The second two, 5. Make that negative 5. Factors like this. So the answer is x equals 5, or x equals 2/5. Are these both good answers? I just gotta find out. 2/5 plus divided by 2/5 5 and 2/5. That is 5 and 2/5 equals 5 and 2/5. Oh, check. 2/5 is good. Now let's check 5. Oh, all right, it's good. 5 and 2/5 equals 5 and 2/5. Both answers are good.
Second. So, x parentheses 5x minus 2, x squared.
Oh, that's right. And 2 terms.
Yeah,
Factor of
ban
that.
him, bro.
And what's left is x minus 5.
Ban him.
2 terms.
You're good.
They have a common factor of 5x minus 2. So I factor out 5x minus 2, and what's left is x minus 5. I'll let you guys go. Any questions? 15 problems, 5 points each. See you on Monday.
Just make sure you post that on there, OG.
Okay. I will.
OG.